Hey everybody, thanks for tuning in. I got a little video lesson for you guys today on motion, specifically displacement, velocity, and acceleration, and kind of how they tie into calculus. And so there's a few things right here, and as you go through this video, I hope you take a few notes and jot down some formulas, and you also get to see a couple examples. But if you think about something like throwing a ball, and you think about it represented as time. And so whether you're throwing a football, baseball, or just picking up a piece of trash and throwing it in the garbage can, you can think of you throwing it as kind of maybe traveling along some parabolic path. And the idea is that if you think about this as displacement, the idea is as the time kind of ticks away, maybe 1 second or half a second, 2 seconds, after a couple seconds that ball or that football lands, and it's traveled along this arc. If we represent that with this displacement function, there are some relationships that original function has with the velocity of the object as well as the acceleration. And so there's some new notation. You might think of displacement as like an f of x. I'm going to label it kind of as an x of t to introduce some of this stuff. But the first thing to kind of take note of is that the velocity of an object is the derivative of that object. And so if you think of the displacement as some x of t, or for simplicity, f of x, some function, the t just represents time. Then the derivative you could label with the prime. If you're using f of x, you'd write it as f prime. But that first derivative is the velocity of the object that you were referring to in the first part. If you think about us sketching the derivatives, if you think about the slope right here, at that moment, the velocity, again, the slope, the velocity, is 0. And that's that moment where that football is no longer going up or down. The velocity is 0. If you take the second derivative, which we could write with 2 primes, again, 2 primes, the idea is the second derivative is actually acceleration. And so this idea of this relationship between the original, the first derivative and the second derivative has some interesting connections with motion and physics and some of these things. All right. So let's look at kind of an example here real quick just to dive right in. If an object moves in the x direction, that just means horizontally back and forth. It's moving to the right, moving to the left, whatever. With the displacement from the y-axis is given by a function. That's all we need to get started. Find equations for velocity and acceleration. All right, so you can think of this cubic function as the original. And so the velocity equation is just going to be me taking the derivative of x. You can also think of it as x prime if you want. So lots of different ways to label these things. Here we go. I'm going to apply the power rule from earlier this week. We're going to have 6t squared minus 20t plus 5. Bada bing. That's the velocity. And if I find the acceleration equation, that's also the derivative of velocity. So again, I power through this. I would have 12t minus 20. And boom, we have our displacement equation. That was the original. And then we've got velocity acceleration. If you want v of 2, this means what's the velocity at 2 seconds or 2 minutes or whatever the units are. But that just means I got to plug in 2 into my velocity equation. So wherever there's a t, I would substitute a 2 in. Come on, moving in slow motion. All right, so I've got 24, right, 6 times 4, minus 40 plus 5. So it looks like I've got negative 16 plus 5. What is that, negative 11? So that would be my v of 2. And again, if I wanted v of 4, I would do the same thing, but plug in a 4. For the sake of time, I'll come back to that in a bit. But if I do a of 2, then I would do this guy, whoosh, plug in a 2. So 24 minus 20, it looks like a of 2 would be 4. I should have put units on here, meaning like it's traveling at feet per second or something, but shame on me. We'll figure that out as we go. All right, let's get a little bit of more background. If I'm moving too quick, just pause the video or something, but this is just the computations, but let's go back to a little bit more vocab. We've talked about increasing and decreasing already a little bit this year, but let's kind of recap it. If you're asked any time for the whole time we're together if a function's increasing or decreasing at a certain point, you got to go to this logic. It says if f is increasing at any point c, remember that could be, that's usually given, you know, at point 2, at time 2, at x equals 6. That's going to be a value. What this says is that the derivative, the derivative is positive. Anything greater than 0 is positive. If f is decreasing at any point, then the derivative is negative, less than 0. So, quick little thing, if right here, v2, that's the derivative, it was negative, we could say that the function is decreasing at t equals 2. Again, we're looking at the first derivative. I can't say much about this right now, at least in terms of the original function, because this is the second derivative. But I can say that with this example, it was decreasing, because it's negative, when the time was 2. That was the input that we plugged in. Okay, another thing that's kind of new, and this is sometimes hard to get our head around a little bit, is many times you'll be asked if an object is speeding up or slowing down. Think about when you're in a car, or when you're, again, throwing an object. What does that mean? And sometimes people think that it's tied directly to acceleration. But that's not really the case, so please be careful. Here's the definition that you want to get comfortable with. It says, if velocity and acceleration have the same sign, the object is speeding up. If velocity and acceleration have opposite signs, so same sign versus opposite signs, then the object is slowing down. If you think about just a quick car example, the idea is if your car is moving in one direction, because velocity takes in the count the direction. So let's say it's moving in the positive direction, or we say the car's moving forward. But you hit the brakes, you slam on the brakes, you de-accelerate, so to speak. Well, when you hit the brakes, the acceleration is negative. You're de-accelerating. And so with this example, your velocity is positive, but your acceleration would be negative. One's going one way, one's going the other way. And I kind of see this as them kind of working against each other. You know, you're trying to move forward, but something's literally slowing you down. And when you have that case, that's what we call slowing down. Another not great example, you know, if you're running in this direction, and then someone comes from behind you and pushes you, again, in that direction. So your velocity is going one way, and then someone kind of pushes you and gives you a nudge in the same direction. You probably stumble and fall over, at least I would, but the idea is both of these are positive. They're both going in the same way, and this would cause you to speed up. So let's go back to, or let's look at this kind of in a different way. If we go back to our example, same function. Is x increasing or decreasing when t equals 2? Well, if v of 2 is negative 11, we say that it's decreasing because the derivative is negative. If I find t of 4, again, I would have to take my derivative, plug in 4. I'm a little worried about time because my video here is going to cut me off. But again, we're looking at the sign. If I'm asked for speeding up or slowing down at t equals 2, I have v equals 2 is negative 11. What I need to find is a of 2. And really look at the signs. So I have it. I have the work over here. A of 2 is equal to 4. I really hope I got that right because I didn't check my work. But what I have is I have one negative value and one positive. So I can think of these as they're working against each other. And we can say that in this made-up example, the object is slowing down because velocity and acceleration are opposite signs. I'll give you some additional examples in class when we see each other soon. All right, last page here, just a little bit about other notation. We talked about kind of the hierarchy with derivatives, but again, we talked about velocity is sometimes equal to v, sometimes it's v of t. If we're talking about displacement as x, it would be x prime of t. But another one that comes up just to kind of make you aware with and aware of, and we'll spend a lot of time with it, is sometimes it's written as dx dt. And it's called a differential. These are called differentials. But you could think of the d as if you say this, you're saying the derivative of x, that's the numerator, with respect to t. And the t in this case is time. You're talking about the units, the variables. And so when you think of acceleration as a, or a of t, or the derivative of velocity, again, it goes by a lot of different names. You could also think of it as the derivative of velocity, dv, the derivative of velocity with respect to time. The rate of change of velocity, the derivative of the derivative. Again, it gets kind of confusing. The last thing I want to say about here in the last minute is just the idea of speed. If you're not taking physics especially, speed is the absolute value of velocity. Speed, the direction doesn't matter. If you are parking your car in your garage or a parking spot and you pull into the spot, you're going forward. Your velocity would be positive. And then when you back out of that spot, or you're backing out of your driveway, or you're going backwards, and you put it in reverse, your velocity would be the opposite. In this case, it would probably be negative, depending on the orientation. But if you pull into the spot at 3 miles per hour and then you back up at 3 miles per hour, you'd have a positive and a negative velocity, but your speed would be the absolute value. Your speed would be the same. So just something to think about. Thanks for tuning into my video. Thanks for your patience, and I will talk to you guys soon.